Now let us discuss few of the illustrative examples. The first question we have is W and X are optically active isomers of C5H9Cl. W on treatment with 1 mole of hydrogen is converted into an optically inactive compound Y, but X gives an optically active compound Z under the same conditions. Give structure of W, X, Y and Z. Now these are basically known as word problems. In these types of problems you will be given a information about only one of the reactant or the product in the reaction. Now what happens actually, if the information is given about the product, then it is quite obvious, then we need to think about the backward reactions, and if the information is given about the reactant, then we need to think in the forward direction. Now in this question, what is given as, we have C5H9Cl. C5H9Cl has two optically active isomers. That means in this particular compound what we will have is two isomers of C5H9Cl which are optically active, which means there will be one carbon in this formula which will contain all the four different groups, as in the compound could be, suppose we have two structures, we have C and then we have to think about the four different groups which we can arrange in this particular compound to have an optically active isomer. So one of the isomer can be, that is C, then we can have ethyl as a one group, hydrogen as the second, Cl as the third, and CH double bond CH2 as the fourth group. Now this carbon has got all the four different groups, so this could be the optically active isomer. The second optically active isomer of C5H9Cl could be, we have a carbon in the center, one group can be CH3, other group can be H, third group can be CH2Cl, and fourth CH double bond CH2. Now if these are the two optically active isomers, now we need to check which will be X and which will be W. Now as per the information given in the question, that W on treatment with 1 mole of H2 gives optically inactive compound. That means in an optically inactive compound, that is Y structure, will have two similar groups. Now the role of 1 mole of H2 is that the structures we have assumed for W and X, in this we have assumed a pi bond, that is an alkene in the compound. So when 1 mole of H2 is added, then what will happen is that this pi bond will be reduced to alkane. Now suppose in W, if I add H2, then it will form C in the center, then Cl as a one group, H as the second, third group could be CH2 CH3. Now the fourth group in the W was CH double bond CH2. Now when H2 is added, so it will be reduced to CH2 CH3. So now this particular structure has got two ethyl groups which are same. That means this will become optically inactive. So as per the information given, that W on treatment with 1 mole of H2 is converted to optically inactive compound, that is Y. So what we can assume is that the structure we have got after the addition of 1 mole of H2 is optically inactive because it has two same groups, that is CH2CH3 and CH2CH3, and this structure has been obtained from, that is CCl 8 CH2 CH3 and CH double bond CH2 group. So that means as per the information this structure will be W. Now the next structure we have is the, which we assumed, that CH3 CH2Cl is the other group, then H, and then we have CH double bond CH2. In this if you add H2, what you will get is CH3